In this episode's layout update, we'll see how my wiring is going and the start of some track work, including a key decision I needed to make before digging in. That will lead us into a little bit about structures, featuring a new bridge that I built over the Platte River. And finally, we'll take a look at some Exactrail beer cars that I recently bought, all right here on the 87 Show. In our layout update, we'll take a closer look at the wiring and talk about some of the planned control components. Having run most of the wiring when the modules were being framed, I now needed to connect all of those wires together between them. It used to be common to use Cinch-Jones connectors for this, but I noticed that the Fremos standard now calls for Anderson power pole connectors, so I decided to give those a look. I eventually chose these and ordered nearly 200 of them in 6 colors to match the wires under the layout. There is some assembly required, and I highly recommend soldering the contacts instead of crimping them, but they do go together quite easily. The only trouble I've had is with the smaller gauge wire, which requires that you push on the back of the contact in order to snap it into place. I've been using one of my jeweler's files, although a tool is available for this very task. I also had to make a multi-bus connector in order to bridge the east end of the yard to the west. Part of this wiring arrangement fulfills the same purpose as the old fish tank wiring, which was to isolate the last 2 feet of track before the detachable sections and cut the power when nothing is connected. This is another area where the power poles really shine, and why I decided to use them. Their modular design allows me to make any kind of plug I need to, and do so with the color and size of wire that I want, something I could not do using the trailer plugs. As before, the drop connection has a wiring block that carries power to the track beyond, while feeding back to the isolated section when connected. The first section of track laying has taken place on this module using micro-engineering track and turnouts, and this presented me with a bit of a wiring issue, mostly due to not paying attention when using insulated rail joiners. Microengineering turnouts are designed such that the frog rails are supplied with power from the next section of track to connect to them, not from the point end. If I had noted this beforehand, I would have eliminated the insulated joiners on these rails. Instead, I had to solder some additional feeders for continuity. The frogs are dead right now, but I do have plans to solder a feeder for them anyway, just in case they need to be juiced later on. I'll be using tortoise switch machines on this layout, so I can use the contacts on those to switch the power. I also tried gluing the included head blocks to the turnouts before installation, but this proved to be a bit fragile, and frankly a little dangerous, as glue could get the switch points stuck in a heartbeat. Instead, I used a little wood glue to attach them to the roadbed, not to the turnout itself. Speaking of roadbed, one important decision I had to make before proceeding was whether or not I was going to use cork roadbed for this part of the layout. After looking at photos of the prototype and looking at similar secondary lines elsewhere in Denver, I decided not to. I didn't feel that noise would be an issue as track speed is held down to about 10 to 15 miles an hour, and the prototype track was pretty down in the weeds, so to speak. So the cork will be reserved for the Colorado and Southern and Santa Fe tracks that lead from Rice Yard to Intermountain Junction, and the joint line eventually. If I had the space, those tracks would continue to South Park Junction, South Denver, and the start of the joint line someday. For now, I'll be focusing my efforts westward towards the Platte River and Lakewood. Now, I did mention control systems at the start of this, so the plan for controlling this layout is to use tortoise switch motors and Digitrax DS64s so that all of the turnouts can be thrown from the throttle. I've also decided that track power should be divided into electrical sub-districts using Digitrax PM42s. This will effectively eliminate the need for control panels around the layout. Instead, specific areas will have a utility panel with the control cards and breaker switches on them that need only be dealt with in the event of a serious defect or wiring anomaly. I feel that the classic model railroad control panel, which at this point is a holdover from DC control, is not really necessary with all the available features of DCC systems today. This layout will endeavor to be a case study in that. It should be noted that I'm using N-scale Code 80 rail joiners to join the microengineering track. These go on fairly easily, though they do require a little bit of narrowing for good electrical contact and good fitment. Now, I'm soldering feeders to every single section of flex track, so electrical continuity isn't that big of an issue. But it's really your call. My reasoning is that they seem to go on better or are easier to work with than the microengineering joiners. So like I said, it's your call. Now, let's take a look at how I built my bridge over the Platte River. Let's see how I made a CNS-style beam bridge to cross the Platte River. I wanted to get this done before the rest of track laying, so I wouldn't have to fiddle around with a temporary setup, and I could lay track accurately from the ends of it. This is the beam bridge that I based on Jim Ferentz's article in the March 2016 Model Railroader. I did make a few design changes, including a different style of railing, as the 4x4 post style was a bit fragile for my liking, so I'll be soldering together a steel railing later. I start by placing a strip of masking tape sticky side up on a bit of plywood to hold the bridge ties in place. For these I used scale 8x10s turned upright, with the 8-inch side facing up. I stained the material first, and then cut the lengths I needed, making 17 of the 19-footers and 64 of the 11-footers. These are laid in 1 long and 4 short sequence, with the exception of the center, which has 3 short ties on either side of the long center tie. Once all the ties were all laid, I glued the 8x8 guard ties along the outer edges of the short ties, making sure to stagger their placement to avoid having a joint along the same ties. Finally, some non-weathered Code 83 microengineering rail was secured to the ties using Walther's glue. With all of that dry and tight, I removed the bridge deck from the plywood strip by cutting the masking tape at the ends and then carefully peeling it off the underside of the track while it's facing down. Next, I added the support girders, made in this case from 1/4-inch evergreen I-beam. These were laid with 2 beams directly under the rails, with 2 more in between, and another 2 just outside of them. All of these were attached with Walther's glue as well. Lastly, I added some cross-bracing to the underside before painting it all flat black. The smaller details such as planking, railing, and the nut-bolt washers can be added later. I'm also making this bridge removable, both for maintenance and transport, in case the modules have to go anywhere. As far as the abutments and center pylon are concerned, I made these out of 3/4-inch plywood with the edges beveled on my table saw. The center pylon was made by gluing 2 beveled pieces back to back, and then trimming down the width. The parts were sanded and coated with Woodland Scenic's concrete topcoat, and then fastened to the riverbed from underneath using wood screws. I pre-drilled these parts to prevent splitting. The abutments had a little shape carved into them at the table saw, but they needed a little shimming and a way to disguise the plywood ends. I did this with about 60,000 inches of styrene, shaped to fit a little wider than the main structure, simulating a cap, but eventually I filed this down so that it simply served to shim the part and cover the evidence of plywood at the top. So that's how far we made it on the bridge thus far. We'll stop at this point and turn our attention back to the bridge itself, which still needs walkways and railings, as well as all those nuts and bolts and bits of weathering. And we'll cover that next time. See you then. A lot of this bridge design is speculative, as the original wooden bridge in this location was not replaced after the 1965 washout. Intermountain Junction was abandoned and mostly torn up, and access to the westward line now came off the Colorado and Southern's west side line. I could have stuck to the prototype and had a significantly longer mainline run by copying this, but I would have had to bypass Rice Yard to do so. I think my fictionalized arrangement is a bit more interesting and has some operational implications for another project that I'm plotting. Anyway, that'll have to wait for another show. For now, this is a brewery-based railroad, and what kind of beer line can run without a few beer cars? Cheers. Breweries make a great industry on model railroads, and real ones as well, by virtue of the amount and variety of carloads they move. Bulk loads of raw materials are brought in on the rails, such as hoppers full of grain and sand, particularly for bottle making, dry box cars full of packaging supplies, reefers full of hops, and sometimes tank cars, depending on the kind of adjuncts being used in the beer-making process. Of course, all of that inbound material goes back out in the form of hopper loads of spent grains, which are usually shipped to feed mills, and 62-foot insulated boxcars designed expressly to haul beer. At the last Rocky Mountain Toy Train Show, here in Denver, Exactrail was selling some of their wares from their booth, and this trio of beer cars lettered for Mopac, Western Pacific, and Southern Pacific were a nice catch. At $30 apiece, they were a little more expensive than my BLMA beer cars, but the overall quality of the Exactrail car still makes this a very good price. There are many separately applied and very fine details, making it almost a crime to put anything but Sergeant Knuckle couplers on these. KD number 58s will nevertheless do well for both appearance and operation's sake. The trucks on the Mopac and SP cars are painted to match the car body, while the Western Pacific car has very small stenciling on the trucks that reads 380, which matches the build date on the car. The production dates of these cars places them well to the end of the Colorado and Southern era, so perhaps a little renumbering is in order, but it's a small detail. In any case, these cars are going to look really good when they're finally weathered. Now, Exactrail offers a lot of paint schemes that fit well into the late 70s, early 80s BN framework, and if I'm feeling like moving the clock forward to 1979 or a little later, these cars should fit right in. I'm definitely looking forward to much more of this kind of rolling stock on my layout. See you next time. So, that's all the show we have for this episode. Thanks for watching, and see you next time on The 87 Show.